Red Bull just built the most aggressive power unit the sport has seen in a decade, and it's already scaring the life out of rival teams. It's their first ever fully in-house engine, created with Ford, and early simulations show it's breaking hybrid deployment limits no one else has even touched. The engine isn't just powerful, it learns as it runs, adapting torque delivery, battery strategy, and heat management live, corner by corner. Subscribe right now, because if this thing performs on track the way it's performing behind closed doors, we might be watching the start of a new Red Bull dynasty. Red Bull's 2026 power unit has gone from concept to crisis for their competitors. Behind the walls of the Milton Keynes Engine Lab, a new monster has emerged. It's the first power unit ever built entirely in-house by Red Bull, developed from a clean slate in collaboration with Ford. What started as a risk has become a revelation. This isn't just about matching the competition, it's about dismantling the status quo in Formula One's next hybrid era. For the first time since 2006, Red Bull is no longer relying on a third-party engine supplier. There's no Honda, no Renault, no borrowed tech. This is a 100% Red Bull-led project, and the integration with Ford's next-generation EV and battery technology has produced a power unit that's already outperforming internal benchmarks before even touching tarmac. It's not just the numbers, it's the consistency, the control, and the ability to deliver energy without compromise. Insiders with access to the dyno simulations describe it as unreal. Energy recovery is exceeding predictions. Torque delivery is smoother than any previous hybrid. And the most shocking aspect? The unit remains cool under stress, a critical edge when operating within the tight thermal limits of the 2026 regulations. In a sport where cooling means compromise, Red Bull may have just built a powertrain that needs fewer aerodynamic sacrifices to stay within operating temperatures. What has the rest of the grid on edge is the sheer pace of development. While other teams are still refining combustion layouts or mapping energy distribution curves, Red Bull has already begun full system integration testing. Not with theoretical models, but with real components, real software, and real data loops. Their engineers are not simulating what could happen. They are measuring what already works. The 2026 regulations demand a complete rebalancing of where power comes from. 50% electric, 50% internal combustion. That's a nightmare for most engine builders, who must now extract maximum output from two energy sources without losing drivability. But Red Bull's early tests show a unit that doesn't just balance, it blends. The engine and battery don't fight each other for control. They complement each other under a unified algorithm that adapts on the fly. And let's not forget, Red Bull's success in the hybrid era was always built on aerodynamic superiority, not engine domination. Now imagine that same level of chassis excellence, but finally paired with a fully proprietary powertrain, built to match the team's exact mechanical philosophy. No more compromises. No more packaging limitations. Just one singular design vision from nose to tail, and that vision is already accelerating ahead of the competition. So as the rest of the field focuses on hitting basic reliability milestones, Red Bull is refining details most teams won't even see until pre-season. This is not just a head start. It's a structural shift. And if the rest of the grid doesn't catch up fast, they may be chasing this monster all the way through 2026 and beyond. One of the most startling technical developments comes from Red Bull's approach to modular energy zoning inside the battery pack. Rather than using a traditional monolithic discharge model, their system segments the battery into multiple zones that can be independently charged or drained based on circuit demands. For instance, low-speed sectors like Monaco's hairpins can trigger high discharge torque, while fast-flowing corners shift the energy recovery focus to cooling preservation. This doesn't just improve performance, it extends the life of the battery over a full race weekend. Red Bull has also implemented a predictive deployment system based on live GPS overlays, tire degradation data, and throttle prediction mapping. In simpler terms, the car knows what the driver will do before he does it. When cornering forces start to build, the system preloads energy release into the expected traction zone. This eliminates hybrid lag, the dead space between electric cut-in and engine push. In testing simulations, the car was able to exit tight corners with torque curves that remained linear across changes in grip, gradient, and fuel load. Then there's the new MGUK casing,
constructed from a lightweight high-tensile alloy designed to absorb vibrational harmonics under load.
This breakthrough reduces oscillation from the crankshaft into the hybrid recovery system, meaning less stress on mounts and more precise energy readings. It also allows for a smaller housing, which gives aerodynamicists more freedom at the rear end. While rival teams still fight with bulkier hybrid layouts, Red Bull has already shrunk theirs, and with it, the aerodynamic drag of the entire rear quarter. A major step forward has also occurred in powertrain thermal equilibrium. Red Bull's engine doesn't just stay cool, it uses heat. Ford engineers developed a dual-flow cooling loop that redistributes thermal energy between combustion exhaust and battery cells. Instead of dumping heat, the system cycles it back into the power unit's electric side, preheating cells and reducing latency during full load demand. The benefit? Consistent power deployment even during temperature spikes, an area where most hybrid systems struggle to maintain reliability. What most fans don't know is that Red Bull's engine has been developed inside a full virtual reality simulation rig, where test drivers and powertrain engineers collaborate in real time. This isn't a simulator in the traditional sense. The rig is designed to stress test the interaction between throttle modulation, hybrid charge windows, and brake-by-wire feedback. By linking the engine and driver interface early in development, Red Bull is building an engine that responds like an extension of the driver's inputs, not just a block of power behind his seat. Another key difference in Red Bull's program is how early they began full system stress testing. Most manufacturers isolate components in early development, combustion testing, battery cycling, inverter trials. Red Bull merged all those elements into a single platform 6 months earlier than rivals, allowing them to identify performance ceiling interactions ahead of schedule. That's why they're already talking about energy deployment timing and integration, while other teams are still chasing reliability. And finally, one figure has leaked that sums up the fear across the grid. In a closed dyno test under race-like conditions, the Red Bull Ford unit produced over 870 horsepower at combined peak while staying inside all regulatory limits for flow rate and energy use. That figure doesn't just make them competitive. It puts them at the very top of the projected 2026 performance table. And if they've reached that level now, with time still on the clock, the rest of the grid is no longer trying to beat Red Bull, they're trying to survive the opening rounds. Red Bull's 2026 engine project didn't just focus on raw power, it challenged the very structure of how power units are conceived within Formula One. Traditionally, engines are developed first and then adapted to fit within the chassis philosophy. Red Bull flipped that paradigm entirely. Their design team began with aerodynamic goals, suspension layout, and center of gravity targets, then reverse-engineered the power unit to fit within those boundaries. The result is an engine that doesn't just power the car, it enables the car's most efficient aerodynamic form. The level of mechanical integration achieved is something rarely seen in modern F1. Instead of building around constraints, Red Bull eliminated them. The gearbox, rear suspension, and engine form a unified mechanical module, where torque loads and structural stresses are shared across components rather than isolated. This allows for reduced reinforcement weight, better weight distribution, and smoother power transfer, which in real-world conditions means more predictable handling and reduced tire degradation across long stints. One of the standout innovations is the engine's torque pulse control system, developed in conjunction with Ford's high-performance EV division. Rather than delivering torque in fixed intervals as combustion cycles dictate, the system modulates torque waves based on live telemetry feedback. This smooths out corner exits, prevents destabilizing surges, and gives the driver an almost electric car-like throttle feel without sacrificing combustion power. In simulated wet weather laps, this feature alone reduced traction control intervention by over 30%, a major advantage under unpredictable race conditions. Cooling has always been the Achilles heel of high-performance hybrid units, especially when teams push for tightly packaged bodywork. But Red Bull's engineers approached this differently. By integrating smart thermal routing channels through the chassis itself, they've turned structural components into part of the cooling loop. The benefit is twofold: the engine runs at optimal temperature without oversized radiators, and the aerodynamic team gains back critical surface area to reduce drag and sharpen rear-end airflow. No other team has shown this level of fluid thermal integration publicly. The inverter unit, often a quiet piece of tech in the hybrid puzzle, has undergone a massive evolution in the Red Bull powertrain. Built using Ford's next-generation silicon carbide switching modules, it converts DC to AC with up to 35% more efficiency than previous systems.
More importantly, it generates far less heat during peak transitions.
That opens up opportunities for longer electric deployment phases without triggering energy-saving thresholds, meaning Red Bull can push harder, longer, before dialing the system back to avoid overheating. Red Bull has also pioneered what they call a real-time performance modulation layer. This is a software suite that overlays data from the engine, tires, brakes, and aerodynamic sensors to fine-tune hybrid energy delivery multiple times per lap.
For instance, if tire surface temperature spikes mid-corner, the system can pull torque from the rear axle, send a brief cooling spike through the battery system, and reinitiate full electric push once grip stabilizes. This creates a level of situational control no driver could manually replicate and no competitor is believed to have matched so far. Finally, this engine doesn't just represent Red Bull's leap into the future, it might be the template for the next generation of Formula One design.
By creating a power unit that is not a separate entity but an embedded system within the car's DNA, Red Bull has blurred the line between engine and chassis.
The 2026 machine isn't just a car with a new engine.
It's a single, breathing organism, one that adapts, reacts, and attacks as a unit. And for the rest of the grid, it's not just a challenge to beat it, it's a question of whether they can even catch up.